shows you how much it's used. That was mine from several days ago. So, um, I don't see the lines are still there. So remind me when I. Well, I'll try to remember. So this the book thing is a little bit odd. Let me see if I can knock that. I don't know. Does that do that? Oh, it does do that. Or maybe we'll just go to no lights for a minute. So he says, oh, wait, am I supposed to start yet? Oh, yeah, okay. So he says this is general curvilinear motion. Um, so I'm just going to go back and take a look at some of this real quick. Um, so let's see. This is the erratic motion, has those plots and everything. And he has some examples, fundamental problems, which he puts those. Okay, so he's done one thing. He's taken these problems, instead of clustering all the way at the back, he put these ahead of some of the others, which is interesting. Um, okay, then he does curvilinear motion, rectangular components, which we did, and then a projectile, which we kind of did. He does some examples. Then he does fundamental. Let me see what the difference between the fundamental. Oh, all the fundamental problems already worked for you. Okay. Okay. So then let me just do problems then. Okay, I like ones with pictures. So now this is not. Oh, this is just motion orb. This is not the normal attempt. Okay, so there's the projectile. Where's the problems associated with the projectile? I was going to do some of those, but okay, so there's the projectile. This is all great. Those are the examples. I would think that those fundamental problems would be for the projectile. Maybe I just didn't go far enough down. Let me try to keep going further. Oh, okay, here are the projectile problems. Okay. Okay, so we can do like, do y'all like golf or what is that? Is that basketball? What is that? I don't know what that is. Oh, there's a fair fighter, a ski jumper, but those are, oh, here we go, 899, okay. A projectile is fired from platform A. The shooter fires his gun from B, or no, I got that backwards. B shot the fire from B, and he fires his gun from A at an angle of 30. Determine the muzzle velocity of the bullet. I guess this is the bullet. If it hits the projectile at C. Okay, so this is good. It's almost like you're shooting down a rocket or something. So in today's culture, that's kind of one of those things that happens these days. But he doesn't tell me. Okay, so he shoots a projectile from B. At B. Okay, so what is he missing here? Can you actually solve that? It's 20 foot. I contend there's a problem. If it's fired from platform B, um, okay, so I hate to pick on him. So I don't know what this is fired. This is maybe one of those skeet shooter things that it's shot from there. But do you see? Okay, the projectile is fired from platform B. Okay, so if I shot it really, really fast, like if this is the velocity here versus this versus no velocity, if I had no velocity, it would fall like this. If I had more of a velocity, it'd fall like this, more like this, and even more, I'd go out here more. So if, first of all, I hate to pick on the guy, but if he's going to tell me this, first I have to know the height, and second I have to know the velocity at B. So do you see that anywhere? Maybe it's, okay, so he says this is 1299, that's 1299. Let me rewind backwards and see if they reference this picture and talk about that velocity. So that, the way he's structured is, I don't see where you can solve that problem. So let me roll back up. That's a totally different problem. That's a motorcycle. I didn't even think you can solve that problem with the information. He hadn't given you enough information. There's not enough information to solve that. So I'm going to go on. Do you see a way to solve that without that information? Because there's no way to solve that. Even the other way he could have done it is he could have cheated you and told you how far that was. And then he could have asked you back to that. So determine the muzzle speed of the bullet if it hits the projectile at sea. Not possible. So there might be issues like that. Let's find, okay, a water fountain. So maybe what's going on is they've created new problems, and in the effort of doing so, you've got to make sure you include all the information. Okay, is that 105? That's 104. Well, that's a good one. 106. There was one with a parabola too somewhere. Did I see that? That's a golfer. That's okay. There's a parabola. 91 and 92. Since 91. Okay. So you know what I'll do is I'll trace the picture out, and then I'll drop the picture down. So he says, okay, obviously this is the picture. He gave you this. Without too much, I can just go ahead and say x is equal to, and what I'm going to do, I don't have to do it because he put the coordinate right here at the thing, at where the ball comes from. So x naught is equal to y naught is equal to 0. I'm not even going to write them here. Vx naught t and y is equal to Vy naught, Vy naught t minus t squared over 2. What is this in? He doesn't tell me whether it's in meters or, oh, wait a minute. I think I see feet. So 32.2 t squared over 2. And now I'll have to make this thing go down so I can actually read some of the data. Okay, so first I'll do both of them, 91 and 92. So 91, he says, the ball's kicked at 16 feet per second, and the angle is 30. Vx naught is equal to the component that's this way. Vy naught's the component that's way. So maybe I'll just do it right here. Vx naught is equal to 16, right? 16 cosine of 30, and Vy naught is equal to 16 sine of 30. And instead of figuring those out, I'm going to carry them in their way. Determine the point, x and y, where it strikes the ground. Assume it's shaped like a parabola. So now I've got to move this up so I can write down the parabola. Y, the surface, is equal to minus 0.04 x squared. Now I can move it back now. There we go. And so all I would do is convert this from parametric to that by putting this in. I take the Vy naught over Vx naught t minus 32.2 over 2. T squared is going to be, so the t is going to be the x divided by Vx naught. So I should have done that first. I'll put it in here, and then I'll put it in here. Okay, so I got that. And now I'm going to put that in there, x squared over Vx naught squared. And so now I'm going to put them in with their writings without their numbers. So 16 Vy naught is the sine 30, 16 cosine 30, 30, t minus 32.2 over 2. Now I can put this one, which is 16 cosine 30, and I'll square it over an x squared. That would be the equation of this curve. And then basically I would set the equation of the path of the ball to be the same as the surface, and one of the solutions should come back to this one. So that should make things easy because we'll see why in a second. Putting this in here, if I move the 0.04 to the other side, well, let me just put it like this. And the 16s will cancel, so for lack of a better thing, I'll just say tangent of 30, t minus 32.2 over 2, x squared over 16 cosine 30 squared. And then I can move this over to that side, and it becomes a plus. And I don't know why I left that as a t when that should have been an x. And now I can take out one of them. One of them is x equals 0. In other words, my equation looks like this: ax squared plus bx. So if I put in x equals 0, I get this. So one of my solutions is x equals 0, meaning that they intersect right there. The other one is pretty easy. So if I take the x out, I divide out the x. I can put these two together, which isn't that easy because I'll have to figure out all the numbers. But I'll say 0 is equal to tangent of 30, and for lack of a better thing, I'll say 0.04 minus 32.2 over 2 over 16 cosine of 30 squared, and I'll say x. Now the reason I can do that, I can divide out the x. In other words, this thing should be x times tangent of 30 plus 0.04 minus 32.2 over 2, 16 cosine of 30 squared, and then you take all that, which is the coefficient, you put the x, and here I'll make it a square. So that can be rewritten as this, and then you could take the x off, and then you've got that. So your other solution should be x equaling to moving the tangent over, tangent of 30 over, and slipping all this stuff under it, 04 minus 32.2 over 2, 16 cosine 30 squared. And what I'm going to do real quick, oh, I forgot to switch back to the other, let's see, here, switch back to the other camera, and then what I'll do is switch out of there, and let's see, I'll check the stream real quick, see if it, it'll take it a minute to come up, maybe more than a minute. I'll bring up MATLAB in the meantime. If it'll come up. Okay, so I got that. Let's see. So I don't have good peripheral vision in the sense that I can see all that, but I can try tangent degree of 30 divided by, gosh, 0.04 minus 32.2 divided by 2 divided by 16 times cosine degree of 30, and I put a bracket there and then square it. Do I have to put another bracket? Oops. Yeah, I guess that's okay. But I gotta put, yes I do, I forgot to put a bracket in front of it. Okay. Okay, so I goofed somehow. How did I goof this? You know what? I'm going to break it into its components. I'll break it there. Ooh. So somehow I've done something wrong. Okay, here's what I mean by I've done something wrong. I'll let you help me figure out what I've done wrong. 32 divided by 2 divided by 2 squared. I think I got 0.083. So this number, oh, I forgot to, okay, wait a minute. Let's look at this number right here. I think I forgot something there. This number becomes, okay, let me type it back in. I think okay. No, I think I typed that in right. 16, was that 16? 16 was the speed. 0.08, 0.08, all right, 0.0839 or 93, or 36, no, 39. 39. Now, the problem is, this number is smaller than that number. And so you get a minus, and that's not possible. So what did I do wrong? Oh, okay, so it's, wait a minute. Yeah, you were, okay, so you could see what I was doing there. So what did I do wrong? Let's see if we can figure out what I did wrong. Because I had to have done something wrong. So he says this is the equation, right? Let me go back to the other. Okay, this is the equation. Oops. That's the equation. So it's a minus 0.04 x squared, minus 0.04 x squared. I copied that down, right? So then I have Vx naught. Did I have my Vx naught correct? 16 lifted off. Cosine, I guess it was 30. Oh, here it is. Cosine 30. Then the y naught would be sine of 30. So I got that far. I stuck the t into here. So I got the vy naught, and then I got the vx naught. So then I've got my t goes in here at 32.2 divided by 2, t squared, which is now x squared, over vx naught, which is that, cosine 30. So I got that. So I've got this term is the term I'm staring at. Right now, I'm unconcerned about that term. And I'm putting this term on this side, became a minus. So, oh, you know what? I think I'm okay, because when I took this term to the other side and then divided by this term, when I took it to the other side, I ended up with a minus sign on top. So that is actually okay. So now I get 0.04 minus that, but let me move it down. Okay, let me move it over. 0.04 minus 0.0839 over, I do not know the tangent of 30 degrees. Tangent degree, 30 degrees, 5774. 0.5774. And so now I get some number which I may have had that in the previous. Okay, it's hard to go back and forth in my glasses here. Okay, so let's look at that one. But, okay. Ooh, what happens if I, oh, okay. Okay, let me stare at that for a minute. Okay, 13.1652. Maybe that's the answer. But we're going to check it. 0.5. Oh, 13.1652. 1652. So we're going to put a question mark, and we're going to try to check it with everything. And you know what we'll do? I think what we'll do is this. Okay, so I know, let's just sort of say to ourselves, okay, what I'm going to do is I'm going to say x equal to 0, or yeah, we'll go 0.1, oops, I hit the wrong button, 0.1 to 15. So that'll give me a whole bunch of values of x. First one I'm going to do is say ys for the surface being minus 0.04 times x, and I have to have a period and then a square, and I get a whole bunch of values. Ooh, did I not? What did I do? Undefined. That's because I didn't put the equal sign. Duh. Now, so now yp from a projectile, oh here, let me come up with this. Vx naught would be equal to 16 times cosine degree of 30, and Vy naught would equal 16 times sine degree of 30. And now I'll say y of the projectile equals to. So what you've got this time, you've got Vy naught divided by Vx naught times x minus 32.2 divided by 2 times, and I got to put this kind of in brackets. What I'm about to put in here is kind of this. I'm going to do this way, and I'm going to do it off of this. So what I did is I put in this one. I did put in tangent, didn't I? Well, I don't have to because I've got Vx not Vy. So now I've got this, so I can just put in x squared divided by Vx naught and then square that. So I actually don't need this yet. Okay, so x, you have to put a period, squared divided by Vx naught squared. Oops. Oh, that's an at symbol. I think I've got that right. Oop, did I not do? Oh. Vx, where did I put the Vx? Is that a 0? Oh, it's saying, did you mean? Oh, okay, yeah, that's what I meant. Okay, so it's helping me, and I'm trying to correct what it's trying to help me with. Okay, so now if I do a plot, oh gosh, I forgot how you do the, okay, x and y. Of course, one's x and one's y projectile. Oh, it takes a long time. Okay. What? Just, okay. I can do hand gestures? Oh, that's with your touch gestures. Okay, I don't have a touch screen. Now my question is, gosh, it's been so long. Can I do, boy, this is an old, let's see if I can do x and y. What was the other term I used? It was ys. Do you do it this way? Maybe it's done it. I just don't see it. Oh, there it is. So if I want to see it, let's see, where's the zoom? I could say tools. There used to be a, hello, zoom. Zoom in. It's not responding all that fast. So if I zoom in, looks like my answer's around 13.165, which that's what I got here, 13.16562. So I don't know, somewhere right in here. So what I had just done is I plotted this one, and then I plotted this one. Now what I'm going to do is I'm going to go back and I'm going to plot the original ones. The problem is I don't know what my t goes to. So now I'm going to approach the problem a little bit different. So what I'm going to do is I'm going to come over here and say, well, x is going to be equal to this 16 cosine 30, and I'm going to say y is equal to 16 sine of 30 t minus 32.2 t squared over 2. I'm just going to start randomly guessing. I'm going to say, well, the t is between 0 and 2 seconds and see what happens. So how do you do this as opposed to the other? In MATLAB, in other words. Have you seen MATLAB before? Okay. So I'm just going to guess, okay? So here's my guess. T is going to go from 0. I better go 0.1 seconds and then go up to 2 seconds. Now maybe I'm not going as far as I need, so let's make it 3 seconds. It's got to be 3 seconds. It's got to complete it in 3 seconds. And then I'm going to say x parametric, P-A-R-A, is going to be equal to, what was it, 16? You know what, I forgot to, did I forget to write the, I forgot to write the t right here. So I'm about to type this one in, and then I'm about to type this one in. And what I'm going to do is I'm going to create a set of vectors, x and y, that are parameterized by the t. And so I just got to guess the t. And of course you could solve for the t, but for the time being, I don't even want to do that. So it was 16 times, and for the x, it was cosine degree 30. Did I put the bracket on there? Times t. Now what that'll do is produce a bunch of x's, and I'm putting a semicolon to suppress the output. So suppress the output. Now I'm going to do y p-a-r-a, parametric there. 16 times, this time it's sine, did I put the d? Yeah. 30 minus 32.2 divided by 2. And this time it's time t, have to put the period, square it, divided by 2. I'm going to put the suppression right there. Now I'm going to go back to the plot, but I'm going to go also in here and do x p-a-r-a and y p-a-r-a. Now it just, usually it, okay, so obviously I've done something bizarre here. So the question is, what did I do bizarre? Because t is equal to 0 shows a y of 9. So that's obviously wrong. So what did I do wrong? If you look at the y parametric, what I did wrong is I forgot to multiply times t. So let's review what I did wrong. Basically, I forgot to put the t right here. And so I forgot that t. So it became 16 sine of 30. That's why it was way up there. So let's see if we can fix that. And then I'll go back to the plot. And there you go, but I got a problem. So this is the beauty of checking your answer. So what did I do wrong? Let's see if I can figure this out. Tools. There used to be just a zoom in button. Okay, so obviously I started, if you look at it, the red line is the surface. The other two lines are the projectile. So it looks like I got the slope the same. So it looks like I got the 30-degree slope out of that. Okay, so now let's do this. Da, da, da. But it looks like I've gone way out here on the parametric versus this. So let's see if we can resolve this. So first of all, 2 seconds is way too far. Probably, if that's 2 seconds, maybe that's 1 second. Oh wait, no, I did 3 seconds. So maybe I'll go back and do 1 second, see where I get. But what did I do wrong? Okay, so this, I would believe, which means that this thing's way out there. So if you look at this, minus 32.2 over 2. I carried 32.2 here. Let's see if we can continue to resolve this. Did I type something weird into MATLAB there? I'm going to go back into my, now the x parameter, well, I guess I could have messed up the x parameter. Let's look at the x parametric. So there's my x parametric. So first of all, before I go any further, let me see, there is a preferences, and hang on, let me see, fonts. Can I increase the font size? Let's see what happens. Well, I did it, but nothing happened. So wait a minute. I want to increase the, okay, figure, display, current. I'm trying to make it so the fonts are bigger. There is another way to do this, if they'll let me do this. Let's see. Hang on. Oh, this is an old Windows 10. Let's see. What? Okay. So there's a way you can do this with systems. Let's see. No. Where's the display? Display. Do you see the display? Personalized. Maybe that's it. Oh, come on. There's a way you can do this with, like if you have vision problems. Well, I guess I was trying to make it, it won't do anything if I hold it. Layout? That's not going to do anything. It used to be in preferences. Let's see, let's do command window and see if I can do you see a thing in there for fonts? I see nothing in there for fonts. How about editor? Display. Oh my gosh. Well, anyway, we're just stuck with this. So if you look at this thing, here, I'm going to do this. So this makes things go really slow to have to do. I can go in behind the board. I may have to go back to bring in my own projector and try to plug it in the wall. Okay, so what did I do wrong? Or did I do anything wrong? 16 cosine degree 30 times t. That's the parametric version of x. I don't think I did anything wrong there. Then let's go back to the y parameter. Let's look at that for a minute. So if you look at that, did I do anything wrong there? 16 sine 30, so there's the sine 30. Remember, the angle was from here to here, so the cosine took you that way, the sine took you up. So 16 times the sine of 30 times t, which I forgot the first time, minus 32.2 divided by t. Divided by 2, and then multiply that. So precedence of operator means the division and multiplications occur simultaneously. So what happens is it reads from left to right. It does that, divides by 2, then takes that value and then multiplies times t, which it already did. And looks like I put an extra 2 in there. So, and I have no idea as to why, except I just did. So now let's go back and get the plot. Oh, wait a minute. And this time it appears, I'm not saying it is, zoom in, it appears like I can't tell the difference between two of them. I guess I could get in close enough. So now I feel comfortable that I did it both parametrically and I did it, took the parametric part off and I got the same answer. But what you can tell, now I've zoomed in close enough to where, now this is a problem with resolution. So these two probably should be on top of each other, and I can fix that by doing something crazy like this. I can go in and say, first thing I'll do is I'll say my t, I'll take it to 1.5 seconds, but then I'm going to put a whole pile of values in there. And I'm going to do my x parametric, y parametric, and then I'm going to plot again. Now, if it doesn't come up to be the same this time, I can fix that off of the x components. So now you still see a difference, And at first you might think, oh, they're not the same until you go back. I have to go all the way back to the x value. Good grief. Where's my x value? And this time, how about I go ridiculous, and then I go back. Gosh, I got to go back and find. Those are my parametrics. Okay. There was my y, which I guess I can't officially do yet because, well, no, I can because I did my, didn't I do my x? There's my x. I need to do my y surfaces, which really that probably wouldn't make that much of a difference. I did my x, right? Now I'm going to go back and do the y surface. Now that was my error. Now I'm going to go back and do the non-parametric version, which was done out to the plot, and that's an over. Oh, I am in zoom in. Oh, okay. Oh, okay. You can scroll in at it, and so now you start seeing that everything does kind of coalesce. And your answer is 13.1652. So, in fact, you can do this two different ways. I mean, you could plot it, find the solution. You could do it parametrically. Technically, to do it parametrically, you would have to find the t at which they equaled, which would be a little harder than what I did. Or you could do it the equation of the surface and the equation of the projectile. And then I think I like the idea of doing it, getting rid of the parametric part and doing it non-parametrically, and then finding the y as a function of x, and then solving it. So I stumbled like, how many times did I stumble? 3 times or 2 times? I don't know. So I thought I stumbled here, but my brain shut off and I didn't carry my minus, so I got that. Then, so a lot of times if you have problems like this, so what you saw is me solving the problem in an unscripted way. In other words, I could have brought in a sheet of paper and I could have written everything perfectly. But I don't think that's conducive. And the reason I don't think that is because for years I went through all these as a comparison. I went through all this thing where I took all these computer courses. When I took all these computer courses, this is great, and I learned programming and stuff like that. It wasn't until I worked alongside a group of 3 or 4 or 5 people who were working in a working environment. And one of the biggest problems you see in there is that everybody stumbles. What do you do when you stumble? And that's the thing, is if you think you're supposed to get everything right the first time, you're delusional. And so what you need to be able to do is calmly go back, figure out you goofed up somewhere, go back and solve it. What I saw in in that environment with those guys that were programmers, they calmly stopped, looked at the manual, looked at what they did, went through, figured out. So the biggest key of programming is not programming, it's debugging. And so debugging is what a programmer does, because they never get it right the first time. And finding your errors is what an engineer does. You never get it right. I mean, if you get it right the first time, that's great. That means you've probably done it several times. And even if you haven't, I mean, I've done these problems several times, and I stumbled through this, and you saw how I just kind of fixed it. Now, a lot of people will get, as a professor, they get very upset at themselves, and they want to do it perfect because they want to show you perfection. I'm not here to show you perfection. I'm here to show you how to do the problems, and part of the doing the problems is making a mistake. So I just come up here and do stuff. So I mean, I'm not going to script it. I'm not going to work the problem beforehand. I'm not going to look at the problem beforehand. I'm basically going to show you what you might experience in going through this. And I hope that is more conducive to learning than just me taking a sheet of paper that, I worked out a couple days ahead of time. So you'll see me do this a lot, where I stumble, I trip, sometimes I'll stumble and trip and not have time to complete it. This time I was lucky. And sometimes I won't trip. Sometimes I'm okay. I had that much tea so far, so I probably did not have enough. Um, and so that might be part of the problem as well. So there it is, and whatever it's worth. I'm going to do that most of this week. Just pick a problem. I hope I could get through 2 problems. I'm also going to try to go out and find a few that I've already done online and put out there. But I noticed the guy, he has a whole bunch of these in there all throughout the book. And how did I'll go ahead and cut this off as far as the streaming, but how did did anybody